This question belongs to the topic engineering mechanics from the subtopic conservation of energy. Okay, and here it is, the block, the 2 kg block as shown in figure, top view, rests on the smooth horizontal surface and it is attached to a massless cord that has a stiffness of 5 Newton per meter. Cord is hinged at O and is initially unstretched and always remains elastic. The block is given with a velocity v equal to 1.5 meter per second perpendicular to the cord. The magnitude of the velocity in meter per second of the block at the instant the cord is stretched by 0.4 meters. At the instant cord is stretched by 0.4 meters, right? So here is the hinge given to you, here is the hinge given, and on this hinge there is a elastic cord, and then to this a block is attached. To this a block is attached. The mass of the block is the velocity of 1.5 meter per second is given, and the mass of the block is 2 kg. Mass is equals to 2 kg. Velocity of the block or initial velocity of the block is given as 1.5 meter per second. 1.5 meter per second. And the stiffness of the cord, and this is the cord given, and this is the cord given. Stiffness of this cord is equals to 5 Newton per meter. 5 Newton per meter. The stiffness is given to you. And what else? The cord is stretched by 0.4 meters. The cord is stretched by 0.4 meters. So he is asking you, when the cord is stretched by 0.4 meters, what will be the velocity of the, what will be the magnitude of the velocity of the block? Okay. So here, right. So don't think that this block is sliding on the cord. It is not sliding, it is attached to that, right? So once this is undergoing rotation, this cord will get stretched. The cord will get stretched. So now, applying applying conservation of energy. So this cord is behaving like a spring. This cord is behaving like a spring. So at the instant, for the initial you are giving input kinetic energy plus spring energy. Kinetic energy and spring energy at first point is equals to kinetic energy plus spring energy at second. So at here it is saying that the cord is unstretched. Cord is unstretched means no spring energy or no strain energy is stored in the elastic cord. So I can write this as half mv1 square. Half mv1 square is equal to half mv2 square. Half mv2 square plus half k delta square. Half k delta square. So this I can write it as half and half will be cancelled. Half and half will be cancelled. So mass of the block is 2 kg and velocity is 1.5 meter per second square, and this mass is 2 kg and velocity v2 is not known to you, plus this would be k is 5 and delta is 0.4 square, right? So upon solving this v2 you will be getting this as 1.36 meters per second, right? 1.36 meters per second, so which is matching with option A. Okay, so this will be end of the answer. Simple question.